that's the philosophy.
Jordan was a constant.
Hey guys and gals, hey guys and gals. Sorry about that. Oh, it's so bothersome when you have a video tabbed up and then it just jumps right to the next video. Isn't that amazing? Goodness gracious. Alright guys, gals, appreciate you being here. Appreciate you hitting that play button. Welcome, welcome. Thank you for stopping by the channel. You know, I love that over here. Truly do. Truly do. You beautiful, intelligent people wanting to learn, wanting to grow. Let's go! Every single one of you. Awesome. Sawsome. Turn that up. Turn that up. Quickly, this is for you, parents, homeschooling parents. Here to support, here to help. I imagine there's a lot on your plate, a lot for you to do. So here to help. Hopefully I can help your child learn and grow. Again, just to let you know, I am teaching mathematics over here. Grade 9 and up, basically. And I'm sticking to the topic. Teaching only mathematics. That's what you want, right? So that is what we're doing over here. Any students, if you're looking for additional support on YouTube, it's great to have you as well. Maybe your instructor sucks, you know, it's not so good. And you're here on YouTube looking for more support. Here to help you as well. Hopefully I can help you out. Again, if you have any questions, concerns, or any specific areas and or topics you would like me to do in mathematics, just let me know in comments down below. All right, turn it up. Appreciate you being here. Let's get to work. Let's get to work. Flick that switch in the old membrane. And let's do some mathematics. What do you say? Okay, let me just clean up this quickly. I guess I should check the stream, make sure we're good. Assuming we're okay, hopefully we are. Because to be honest, I thought that was a pretty good intro. I won't lie, I liked it. Let's see. All right, please be working. Sure we're good. Yes, 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 yes. That is awesome sauceum. All right, had to have a quick drink of coffee, and we're gonna get to work, boys and girls. Let's get to work. I'm gonna quickly do like a quick shape here. Something to that effect. Okay, so this could be like, I don't know, for example, this could be a series of pipe, something to that effect, right? I don't know, it's gonna be, oh, terrible, 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 terrible drawings. So, let's just say it goes kind of something like that. And then I know it's not going to be perfect, guys and gals, but let's say it's going at that angle. And then we just 90 degrees again, and then there we go. So we have a piping system that's kind of going like that. Sorry, trying to draw fast, and we're not going to be perfectionists over here. Okay, so I wanted to give you an idea. So it's kind of like a piping system. And you used some measuring instruments out in the field, and these are the angles that you got, and it worked out to that. Okay, Now, to let you know, it's just like anything. We have a narrow angle, which is less than 90, right? We're going to call this one Y, I guess. And it's equal to 60, okay? As you see there. Now, the straight line concept works here as well, guys and gals, okay? Because you kind of have, if I extend this line, right? This is our wider angle. And remember the terminology, corresponding angles, right? So therefore, this means this is also X right there. Okay? With that said, we can simply, let's see, just want to kind of keep it like that so you can still see it. So looking at this, we can see that this is 180 degrees. Just gonna go like that, okay? 180 degrees. All I did is extend the line. So that's pretty much how you can solve that problem. So X is going to be equal to, same concept, guys. It's really easy. Just kind of got to sit and think a little bit, right? Wasn't too bad. Subtract Y. If I extend this, I'm going to go 180. I'm going to try to get through this quick. I'm trying to get through the problems a little bit faster, guys. Do a bunch more, okay? So therefore, X is equal to, I know that 8 take away 6 is 2. So it looks like we have 120 degrees. Now that's greater than 90. This is our wider angle, or obtuse, so which makes sense. 120 degrees sounds pretty reasonable. All right, there we go. Yes, there we go. All right, let's carry on to another one. This is like a hospital gurney. So I'm gonna it's not gonna be perfect, but we're gonna try to draw one. So we'll pretend this is the bed part, the gurney. Okay, there we go. Why is that lagging a little bit? I'm just gonna erase it. I don't know why it does that. I get a little bit of lag for some reason. Not opacity, 32, and turn that off. Okay. And I'm gonna just draw the legs as kind of a, as a line. Okay, so we're gonna go like this. And then I'm gonna go like this. Whoa, Batman. That was a terrible line. And like that. Okay. And then we're gonna connect these. Let's see. Let's go like this. Just wanted to see, am I close here? I don't know. That looks good. Okay, and then we're gonna just go like this and like this. There we go. Good enough. And then we're gonna pretend that we have legs connected here. And we'll just, I don't know. We'll do a circle there, and then we'll just pretend one that's kind of rotated. No, that kind of looks derpy. Let's just go like that. All right, good enough. You get the idea. It doesn't need to be perfect. Okay, so what they've given us, now here, let's just draw it in. So right here is 39 degrees. I mean, if you have the proper instruments, you could probably measure that. They have X here. They have W here. They have Z here. And then they have 32 here. Let's just go like this. 32 here. So I'm going to go like this. And then I'm going to go like this. And then they have Y here. Okay? So basically they're asking for all X, Y, or X, Y, Z, and W. Okay? W, X, Y, and Z. So this is how you figure it out. So looking at this, you're going to go, so you have a triangle here. And you know that all triangles, so every triangle, all interior angles add up to 180 degrees, right? So we have, if we do this triangle here, let's call it, I don't know, T1. And this could be T2. Whatever you want to call it. So T1 is going to be 180, subtract 39, subtract W, subtract X, right? And if you look at T2, it's the same thing, except looking at it, we have 180. 180. If I try to write this nicer, then it's just going to take a little bit too long. I'm going to try though. 32, subtract, I'm just going to go Y and then subtract Z, right? You can see that clearly. Okay. Now with that said, now I know I haven't drawn these lines perfectly straight. Just pretend it's a perfectly straight line, guys, okay? Again, when you're sketching and doodling on pieces of paper, you know, you're going to basically do the same thing unless you pull out a ruler, right? So looking at this, we have 39 degrees here and we have 32 degrees here. It's like, okay, thinking of this, all right. That must mean that this line here and this line here are not going at the same angle, which is true, right? There's a 7-degree difference. So with that said, let's talk about corresponding angles, alternate interior angles, same side interior angles. Those concepts kind of are true as well, but how do I, let's see, opposite, those won't really work. We have complementary as well. I'm just trying to figure out the best way to explain this. With this line here, going all the way to here, we can assume, right, this is our narrow angle, right? Because this line here is connected, is basically the angle this line is going at. That must mean that the angle in here also is going to be the same. So because it's a narrow angle, that's a narrow angle. Therefore, X must also equal 32 degrees. Okay, again, it's a straight line, and it's kind of bugging me a little bit too, guys. I wish it was a perfectly straight line, but it's not. This portion of the line here, it's the same line, right? So that means this angle is also going to be 32 degrees. It's just matching. I guess, how else do I say that, right? Alternate angle, I guess, if you will. It is an alternate angle. If you really needed kind of an explanation, I don't really look too deep in those kind of technical. I just know that this is a straight line. It's running at this angle, therefore this angle has to be the same. That's the way I look at it, right? Same thing in turn with this line, right? This line is running at 39 degrees. Well, that must mean that Y is also going to be 39 degrees. Okay? That truth still applies. Okay, you're gonna get this right on the exam. Okay, trust. If you get something similar to this problem, right? So now you know these interior angles. So really, it all works out, right? Really, I could take this triangle here and rotate it. If I rotate it, just imagine that as well. If I take the peak of this triangle and rotate it 180 degrees, this 32 degrees is going to go right there, right? You can look at it that way, right? Maybe you're a visual learner type person, which is, good. Everybody kind of learns that way, majority of us, but there are different ways of learning. But that's another visual for you, right? You can imagine this triangle right here, just rotate it about the peak here, and this 32 is going to end up right there. Same thing with this y. Y is going to be on this side, right? So that's another way of looking at it, right? That'll confirm it in your mind. Oh yeah, those angles are going to be the same, right? If that helps. I hope it did. So essentially we could take any one of these two formulas now, this one or this one, substitute, and we can figure out W or Z. Now, how do we determine what W and Z is? Well, there's two ways. Well, one way is we could take a triangle and go 180. Okay, we can take a triangle. We know that all interior angles equal 180 degrees, right? Same thing with this. If we look at it, all our angles, this one's 39, this one's 32, this is 32, this is 39. Therefore, Z and W are actually going to be the same angle as well, right? So with that said, that must mean that W and Z are also opposite angles, right? If we needed to explain ourselves. Okay, so we'll just use this one right here. And we'll substitute. We'll get 39 minus. Now we're going to have to do a little bit of work with the formula here. W and Z are unknown, right? So minus W minus X we know is 32. Okay, so I should clean things up here a little bit. I really don't want to erase anything. Kind of running out of room. So hopefully, I'm hoping that you guys have been following along. I want to explain, but I don't want to spend a lot of time explaining. Hopefully you've been following. Integer grid. Okay, algebra, just think integer grid. If you understand the integer grid, you should be able to do algebra pretty easily. I'm just gonna bring up the just gotta go here. Give me a sec. I'm gonna bring up some more information for you. Okay. A visual. I'm looking for this. Okay. Close this. Rotate this. Right. Hopefully you've been following and you've seen this. Okay. Integer grid. All right. With that said. So what we want to do is W is negative here, right? If you have been following the series, you'll know what I'm talking about. And I recommend that you follow the series because I explain these little details, how to arrange formulas. And I want to explain it, but I also want to continue moving forward here, right? Some more problems, okay? So we need to solve for W. So essentially, I'm going to kind of explain, but I'm going to kind of go through it a little bit kind of quickly here. So I'm moving W to this side of the equal sign. So we're going to have W on this side, As soon as you do that, W becomes positive, okay? But now we're going to be bringing 180 over. We don't really want a negative answer. But, how do I arrange this without turning the 180 into a negative? That's the thing. I could do it, and then I could divide both sides by -1, because really we want a positive answer, okay? I guess the negative would be orientation, but that's okay. So we're going to end up with, how do I do this? I should have arranged the formula ahead of time. Let's do that instead of substituting here. We need to solve for X, or W. So W is going to equal 180 minus 39, because this is going to change. This is still positive, right? If you see, the 39 becomes a negative. It all works the same, guys and gals. And then we still need to be subtracting. This is still on this side. 180 minus 39 minus. I don't want to change the sign on that. What's up? 180 minus. Oh, did I mess things up here? What am I doing? Plus. What? I should be plussing. What am I doing, Batman? Sorry, guys. I must be tired here. I apologize. There we go. That fixes things. Plussing here. 180 minus, and then minus. That works out. There we go. Because I'm looking at them going, my signs are messed up here. I figured it out. Sorry, guys, for messing you up. I didn't mean to. Essentially, the triangle is like, just to so it doesn't confuse you, really the triangle is this. Equals, if I do this one, it's going to be W plus X plus, well, essentially Y is this one, so Y, right? They add together to give you 180. I don't know, I wasn't focused there, guys. My bad. At least we got it fixed now. One side has to equal the other side. If we add these all together, this is going to equal that side. It still works out. Okay. 180 minus 39 minus X, which is 32. That makes more logical sense. I knew I was doing something wrong here. Well, we got it now. Okay. I know I didn't show the work changing the signs, but essentially we're taking the W is still on this side, yes, but it doesn't. I don't know how to really say that. It really is the same thing. So W is on this side. I'm not changing the sign, but I'm taking the 39 and moving it to this side. It'll become minus 39, right? And which means I'm also going to be moving X to this side. So X is going to be, right? We're going to subtract by X as well, essentially. With that said, I'm not really moving the stuff from one side to the other now. I'm kind of just organizing the formula so that my W is positive. I feel like I'm over explaining now, and I do apologize. Okay, because it's a lot simpler than that. If you move variables with algebra around enough times, you kind of know the little tricks. Okay, 180 minus 39 minus 32. And we need a positive angle, right? That's kind of the goal I was going with here. It's what we want. We don't want negatives. And there we go. W is 109 degrees. Whew! Oh, just let me know in comments if you'd like me to go over that one again. Honestly, I should just erase this whole board and things would be kind of a little bit better, I think, but that's okay. I do apologize for messing that up a little bit. All right. At least we got it kind of sorted out, so that's a good thing. All right. What are we gonna do now? So we did polygons, right? We talked about that a little bit. I want to move forward here. Similar triangles. Let's talk about that a little bit. Okay, similar triangles. Another thing I could actually do is that my backing layer? No. Which one did I write that on? Oh, it's on my working layer? Ah. Darn ski. I should actually move that to my backing layer. That's what I should do. Let's see. Go like this. I can't really do that anyways, but watch this. Check this out. Selection. This is a little bit tricky to do. Hopefully I can get this without messing it up. So now I want to copy that. Copy selection, or no, cut selection to new layer. There we go. And I want to move it to my backing layer. So I moved it up. So now I'm kind of doing Krita stuff now. Now I want to paste. I want to merge with layer below. Okay. Did that work? No, it did not. I think I needed it on. That's what I needed it. So let's try it again. Oops. Oh, I got it twice. Okay, hold up. Oh, I'm really messing this up. Undo, 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 undo. Man, I almost feel like I shouldn't have streamed today. Sorry, guys. You're getting a lesson on how to use Krita. I just want to turn it off so I have more room for writing. Okay, let's do this again. No, I want to move it. Selection. Cut selection to new layer. Oh, I got too many working layers. I don't know what's going on. And then merge with layer below. Now I want to see what layer is locked. Oh, that's what the problem is. Merge with layer below. There we go. What is this? I got two working layers. I need to delete one of these. Backing layer. Did I get it? Ah, there we go. I got it. It's a little bit tricky. There we go. Okay, so I can turn it off now and have more room. That's what I wanted. And I gotta make sure it's locked. If I lock it, then I can't write on it, right? Is it locked? Well, I'm still in that mode. Okay. Yeah, see? I can't write on it. Boom. Okay, turn that off. There we go. We got some more room. All right, so now let's go like this. I want to go like this. We're going to do similar triangles. That's kind of what I was going for here. I think if I have too much information, guys, then it just makes it more challenging to explain everything. It gets too cluttered. And I don't want to have that. I don't want it to be cluttered for you guys. I want you to learn. Okay, so here we have 60. We have two triangles, okay? And we're going to determine, are they similar triangles or not? Okay, so they've given us this information. And then on this triangle, they've given us this information. Again, these are in degrees. And then up here, they've given us this information. So, two signs for Alpine Ski Resort are shown below. The signs are in the shape of a triangle, right? Okay. Are triangles similar, right? Are the triangles similar? So what we need to do basically is we need to figure out this unknown, right? And same thing with this one. The formula again, if I write this properly, then I'll show you guys the proper way to do this work. I should have it on the variables on the left side. That's what I need to do. It'll be less confusing. X plus Y plus Z equals 180. This is gonna make more sense. I like my variables on the left side. It's so much easier to explain and show, right? Clear heads, guys, okay? I'm gonna rectify and clear things up from the last problem, okay? So we're gonna pretend this is X, Y, Z. It doesn't really matter. We could pretend that's Z. So here we got X. This is Z, so that means this one's Y, okay? And this is gonna be X, and this is gonna be Y, okay? So we know. All right, so first we gotta do this triangle, so we can call this triangle 1, T1, and we can call this triangle 2. Whatever you want to do, okay? That works. So let's solve triangle 1, and then substitute, okay? So X is 60. Actually, as a matter of fact, before I get carried away here, we're solving for Z, right? So I'm going to bring the formula here, and then I'll show you the proper way to do this. This is basic algebra. I want you guys to be fully confident doing this kind of stuff. I'm just thinking it in my head. I want to keep it simple for you guys. I don't want to confuse you. I'm just worried about that. Okay? That's what I want to avoid. Okay, we're going to solve for Z. Okay? Whoops. So Z, Z, whatever you want to call it, doesn't really matter. Potatoes, tomatoes, tomatoes, it all cooks the same, right? So we're going to keep Z on the left side of the equal sign. We want it to stay positive, right? That's the goal. So 180 is right beside the equal sign, so we'll just write 180. Okay, that's staying here. It's not moving. The rule is anytime you take a variable from one side of the equal sign, so this is the left side, and this is the right side of the equal sign, okay? Right? The equal sign's kind of like like to explain. Think of it like a teeter-totter. Okay? It's a balancing game, right? So if you have a positive on this side, that same variable is going to be negative on this side. This is the equal sign. Okay? That's kind of the simplest concept I could give you. Okay? So, clearing things up so it doesn't look so messy. Z equals, so Z's staying here. We need to bring X and Y to this side, right? We're taking both of these, and we need to bring it over here. Okay, that's the goal. So when we do that, X is going to become negative. And when we bring Y over, same concept. It becomes negative. That's how it works. It's that easy, guys, right? That's why I kind of recommend to you. And I know the last problem I had the 180 on the left side. I didn't want to. I shouldn't have wrote it that way. And then plus I had my signs messed up. Anyways, this is the right way, okay? Trust. So now it's just a matter of solving, right? So 180, solving or doing substitution, right? X is 60, so minus 60, and subtract 48. Okay, and instead of doing the long subtraction, which I can do to avoid mistakes, we're just going to go 180, subtract 60, subtract 48. Okay, so for here, I get, I might actually have the room, but let's just go like this. Z equals 72 degrees. Okay, that's what I get. Right? Now let's solve this one. It's the same thing, same formula. X plus Y plus Z equals 180. I'm showing the long work, okay guys? So I'm going to arrange my formula first. We're solving for Y. So I want Y to remain positive. I'm going to put my equal sign immediately after. Okay, I want Y to be positive. So I'm keeping Y on this side, on the left side of the equal sign. Okay, the 180 is also going to stay. We don't want to move that, right? We're isolating Y. That's what we want to do, right? Okay, so we got X and Z. So X is going to come over to the right side. It becomes a negative. Z is going to go over here, just like we did for X. And that becomes, I don't know why I get this lag spike once in a while. Anyways, doesn't matter. All right, so now it's just a matter of substituting, guys. I think my problem is I need to start doing these streams a little bit earlier in the day. Okay, 180 subtract, now substituting. X is 60 and Z is 75. We have no choice but to solve this to be able to determine. Now it doesn't matter. All angles in the triangle are going to be 180 degrees. It doesn't matter. That stays the same for every triangle, okay? The values are what are going to tell us, are they the same? Now, to determine that, we already kind of know, right? Based on this, we kind of already answered it, because if you look here, 72 is not 75, right? We kind of already figured it out based on just doing the calculations once. But we can confirm it by continuing our calculations. So if 75 is 3-degree difference here. So I'm going to guess that if that's more, that means this is going to be less. If this is more here, this is going to be less here. Mathematics in my mind, I know it's a balancing game. If you have an increase in one side, you have to have a decrease in the other side. This is going to be, because it's a 3-degree difference, my guess is this is going to be 45 degrees. Okay, let's find out. 180 subtract 60 subtract 75, 45 degrees. Let's go. Okay, so to answer the question, right, obviously they have to be exactly the same in degrees or in value in order to be similar triangles. So the answer is no, they're not similar triangles. Okay, because, well, for triangle 2, the peak is 3 degrees greater, right? So however you want to answer the question, kind of the way I've been saying it, in triangle T2, Z is equal to 75. In triangle 1, Z is equal to 72. Therefore, the angle in 75 is greater than 72, right? Something to that effect. And then your final answer would be no, or not similar triangles, right? Something to that effect. And then I could just use the triangle symbol, I guess. Not similar triangles. Okay? How are we doing for time? I do apologize if I have some... I'm not perfect, guys, but the main goal for me is to catch my little mistakes and correct them for you guys and gals, okay? Again, mistakes is how you learn, and that's how you learn and grow and get better. So hopefully that helped a little bit better in understanding for you guys and gals in regards to, figuring out and solving for a solo variable, right? Such as Z and Y. That's basically how you do it, right? When you move a variable from one side, you have to change the sign. Okay, that's key. Remember those little details. I'm going to try to do a bunch more for you guys and gals so you can see. I'm kind of glad I cleaned up the whiteboard here so that I think I just ran out of memory for erasing. So that you could actually see the problem better without the all the extra clutter. Okay? Which I should be doing anyways. I don't want I want to keep it visually easier for you guys to see the problem with less confusion, because I don't want to do that. All right. I couldn't undo, so now here I am erasing. Okay. I guess it wasn't too bad. Back to pen size 32 pixels. Okay. So we have two photographs, okay? So I'm going to write it up here. I'm just going to go like this. They're basically rectangles. Okay, and then we have another one, which is, I call this scaling, right? It's not perfect, but they're rectangles. Okay. So the one on the left is 15 inches, and this vertical is 12 inches. Now I could draw like make it look like it's a frame. I'm not gonna draw perfectly, guys, here. Okay. Kind of trying to get through this quickly. We're really just grinding math problems, right? Okay, and then the other one here is 22.5 inches and 18 inches. Okay, so the question is, are the two photographs similar? Okay, so these are rectangles, right? I recommend with rectangles, and you could also do it with similar triangles as well. I use a concept that's called ratio proportion. I find it to be the most simplistic method of determining if something is proportional to another. Ratio proportion. Okay, I call it ratio proportion. What it means is, now let's say this was X and this is Y, and I don't know, let's call this W and Z. Okay, ratio proportion basically means X over Y. Does it equal W over Z? Okay, you seeing that? That's ratio proportion in a nutshell right here. So what you can really do is you need one value to compare. So how do I, let's see, without over explaining it, let's do the small one here. Let's go, maybe we'll just work with the 18 because this one has a decimal 0.5. Let's test with the 18, okay, to see if we get 22.5, that means they're the same. So what I'm gonna do is basically same concept, X over Y. Is X over Y equal to W over Z? This is what we're trying to figure out, okay? So what we do is just substitute, right? X is 15, Y is 12, and we're gonna test it. We need to match this value. So we're gonna go W, okay? And if we do ratio proportion, we should get W equals 22.5. Okay, so now I'm going to go 18 right here. Okay, how do we solve this ratio proportion? It's simple. This is how I teach my kid. Just think of it this way. If you have one fraction equal to another fraction, just cross multiply. Okay, I call it cross multiply. I always like my variable on the left. So I'm going to go 12 times W. We're making everything linear. So linear means straight line. Instead of fraction form, we're making everything linear. 12 times W equals 15 times 8. 18, sorry, my bad, guys. I must be tired. I apologize. Okay, so a lot of math instructors, and I don't really like this concept. I don't know if they're trying to make themselves sound smarter or whatever. I think it confuses people more. They'll divide both sides by 12. I mean, the concept still works the same. It truly does. Because essentially you're going to be crossing out the 12s here. The concept still works. It still works however you do it, but this is so much simpler. I just go like this. If we have one side equal to the other side, we need to isolate W so that W is just one W, because essentially W does have a value of 1. Just take the 12 and go rip, boof. Put it underneath a fraction. And then so now we're left with W equals 15 times 18 divided by 12. Okay, and we can reduce here too, guys, right? I mean, maybe your instructor is going to let you have a calculator or whatever. Let's say you don't have one. We could do what's called factoring, okay? So you have a choice. There's a couple of ways of doing it. I call this taking as much meat off the bone, but you have to pick one of these two numbers to factor. Maybe go with the 18. Go with the 18, I think. So we know 12. So you have to figure out some numbers. We know 6 times 2 is 12. We also know that 4 times 3 is 12, sorry. And I'm going to work with 18 because it's the largest number. I'm going to reduce this as much as possible. And so I think, I wonder if 6 would be a better idea. That would be the most meat off the bone. We know that 6 times 3 is 18. And we also know that 9 times 2, ooh, that might work as well. Will that work? No. It won't. We can't use that one because we need a common number. 9 and 2, the only thing that works is it won't work because then we're going to be using 2 to factor. We don't want that. We want the largest number. So I'm going to cancel that. We're going to use 6. 6 is going to be the most meat off the bone. So I'm going to use 6 times 2, and I'm going to use 6 times 3. So this is our factorable number that I'm going to use because it's the largest. And again, I like to go with the idea taking the most meat off the bone. Let me just undo this here. We're not touching the 15. The 15 is kind of hanging out and waiting. Okay? We're working with the 12 and we're working with the 18. That's what we're working with. Okay, guys? And I'm reducing this number and this number. So I'm basically breaking it apart. So we have 6 times 2, right? It means the exact same thing, right? And we have 6 times 3. Okay? So there we go. This is perfect. Now we just instantly reduced, right? So this 6 divided by 6 is 1. So now we're down to, I'm going to move it right here, 15 times 3. I hope you're following. I'm just reducing ahead of time so that it makes the math kind of easier in the head, I guess. Plus, if you factor before you do your multiplication, your final answer is going to be too large, right? Following? You don't want the number too big, then you're still going to have to reduce it, right? So the best thing to do is reduce it before you multiply it. Right? Isn't it easier to, because I could go 15 times 18, all divided by 12, but in the end, I'm still going to have to factor that, right, to reduce it. So it's just way simpler on the brain for understanding to, again, reduce it before you multiply. And as you can see, we're left with 15 times 3, and we're left with 2. Because again, the 6s, that's what we want. That's the common number here. Right? That's what we're looking for, that common number, so that we can basically get 6 divided by 6 equals to 1, right? That's what we want. Okay? Essentially, that's what we want. That's the end goal, right? Okay. So we are going to have to still multiply here, but I think ooh, this might actually work out. So let's see. Okay. 15 times 3. We'll do the long work. You know, guys and gals, the easiest way to figure this out is kind of, if you can count by 15s, if you know 15 and 15 is 30, you could do this in your head. Plus you have, so that's 2 15s, but we're doing 3, so we have one more. So plus another 15 gives us 45, right? That's one way of doing it. Or you could just do the multiplication like this. Go 5 times 3 is 15. Carry the 1. 3 times 1 plus 1 is 4. So that gives us, our final answer here is 45 divided by 2. Okay? Now, of course, we got a fraction here, right? Does that equal 22.5? How do we figure this out? Well, if you don't have a calculator, we could do it kind of this way. Let me just clean this up here. I want to make a little bit more room here so you can see. 45 divided by 2. Okay, we could actually break 45. So here we go. Let me show you something. Think of this in your head, right? We need an even number, right? What's the closest to 45 as an even number? That's 44. So I'm going to go 44. Well, how do we get 45? Well, that's 44 plus 1, right? 44 plus 1 equals 45. Okay, so we could divide 44 by 2. Now, if you know, if we do the long division, we know 2 goes into 4 twice, which gives us 4. This becomes 0, drop the 4. 2 goes into 4 twice. 4, we're left with the remainder of 0, right? So that means 22. We're getting closer. 22. I mean, you can use a calculator, but this is showing the work as well. So now we're going to split 1, right? So now, obviously, if we divide 1 by 2, we're going to end up with decimals, right? Think of a dollar. Think of 1 as a dollar. If you think of it as money, right? Because essentially the number 1 is essentially a dollar, right? And the decimal is to the right of 1. So how many quarters does it take to make a dollar? Well, that's 4, right? So essentially we have 25 plus 25 plus 25 plus 25, right? 4 quarters. 25 times 4 gives us 1, right? In decimal value. I don't have the leading 0, but the leading 0's there, right? So what's half of a dollar? Well, 2 quarters, which is 25 plus 25. If we add that together, we should get 0.50 or 50 cents, right? So there we go. So now we take this 25, that's half, right? It's half. And we add it to the 22, 0.50. We get 22.5. And I do apologize, it's a little bit messy, but that's essentially what we end up with, right? I'm just kind of going over and showing the long work. Okay, guys? then we're going to add the decimal. We get 0.50. Again, when you're adding, you line up the zeros. I could cancel this. I don't need that. So 5 plus 0 is 5. 2 plus 0 is 2. We get 22.5. So the ratio proportion works. Okay? We'll leave that. So therefore, yes, the two photographs are similar. Because our final answer is 45 divided by 2, which is equal to 22.5. This matches this. Okay? Which is correct. Okay, guys, big yays. I know it was a little bit of extra long work. We're doing, lots of little things that we could learn and kind of refresh our mind on. Plus we're doing a little bit of mental math as well, guys. Okay? The idea or concept is to get you to kind of logically think of your final answer, and with doing these little extra steps, I know I'm kind of going a little bit more than I maybe need to. I don't know. We're doing long division, we're adding decimals, we're showing the work. It doesn't hurt to kind of go over that kind of math. Let's say you have to do the exam without a calculator, right? Hopefully you don't have anything too I don't like to divide or do long division with decimals that are kind of too crazy. I don't like doing that. I prefer to use a calculator, but with basic math and knowing your times table as well, guys and gals, that's key, right? Especially with factoring. I call this factoring, or another term, it's called reducing. Again, I'd rather reduce ahead of time. I don't even need to touch the calculator at this point. I could do all the small light work and figure out my answer without a calculator. Because here I would have to probably use a calculator to go 15 times 18. Or I could do the long work. If I could actually write. Right? I call it the long work. Basically, that's the long work, right? But then again, like I said, your final answer is going to be big numbers. It's going to be probably 3 digits, right? What does that work out to? I don't feel like doing the long work. I know 10, 15 times is 150. So another 10 would bring me to 300, but it's not 20, it's 18, so take 2 off of that, so that's 30. 200, I'm doing it in my head. 200 subtract 30 puts me at 170. 270 I'm at. Subtracting from 300, not 200. So yeah, look at that. I just did it in my head, but of course I'm kind of tired, but I'm not making excuses, but it's easy to make mistakes when you're not focusing. You really have to focus when you're tired. You have to focus even more. I think that's it. I wanted to do more again. You guys could see how quickly it takes, how fast time goes by when you're just doing some problems. Again, if you're doing a math exam, man, you're gonna want to smash them quicker than what I'm showing you here. Okay, just realize I'm over explaining. I'm explaining. Hopefully, it's helping you guys learn. A lot of it might be easy, and you guys already know. I don't know your level, right? I could only assume that whoever's learning here might be having difficulties, and it's kind of new to them. All right, so thank you for understanding. You're awesome sauce. Appreciate you watching. I'll see you guys and gals in the next video. Whoever you are, wherever you are, have an awesome rest of your day. Johnny Whiskey Tango Sharp, coding and mathematics. I appreciate you being here. Again, if you like the content, hit the like button. Remember, sharing is caring. And I'll see you guys in the next video. Take care for now. Peace.